Now, how diode works or function? Diode, we can say diode. It is otherwise we can say a rectifier. So this is our what exactly? This is our AC pulse or AC input, and by applying a diode within an AC, we'll be able to get this kind of output pulses in the form of a DC. And this particular output pulses is called pulsating DC or pulsating pulses. So the positive half cycle, again, the positive half cycle on the upper part we'll be able to see here. So this particular negative would be terminated during rectification. So diode used to do rectification. During rectification, what diode used to do? Diode used to only rectify. Here we apply. Here is the diode. If we apply AC voltage over here, here is AC. So we will be able to get here is DC in the form of DC voltage in the form of positive voltage, DC positive. If we apply AC here, we will be able to get DC positive here. For example, this is our transformer. For example, for example, here we apply 220 volt AC. We will be able to get here is 0 and 220 volt. Here is 0 and 12 volt. So this is what exactly we apply AC. Here we exactly we are able to get AC. So here, if we apply 4 diodes like this in the form of a bridge, and we apply 4 diodes, say D1, D2, and D3, what we'll be able to get? We'll be able to get DC out of it here. So from this minus and minus, here is plus and plus. So here we will be able to get plus voltage. Here we will to get minus voltage. So through which we'll be able to draw, or we can connect this kind of wire from here, and parallelly a filter capacitor which is plus and minus, through which we'll be able to get DC over here in the form of a positive and negative. This is what exactly the AC pulses. This is what exactly the DC pulses. Before filterization, before applying this capacitor, CA, before applying this capacitor, we'll be able to get what? This kind of voltages, so this kind of frequencies in the form of pulses. And after applying capacitor where what we will be able to get? We'll be able to get this kind of waveform. So this kind of waveform. So this kind of waveform we'll be able to get. This kind of waveform we'll be able to get after applying capacitor. After applying capacitor. Before applying capacitor, we'll be able to get the frequency format likely to be this in the case of a full wave rectification. And in half wave rectification, we'll be able to get likely to be this, the wave format. We'll do it practically. So for this kind of full wave rectification, we need 4 diode. We need 4 diode or 2 diode. So 4 diode is meant for 0 and 12 volt transformer, and this kind of, for 2 diode we use 12 volt transformer. So we talking about 4 diode and 2 diode. So this is what is the 0 12 and 12 0 12 are the secondary part of a transformer. Secondary part of a transformer. So in the case of FL, this is full wave rectification I am talking about, and this is the wave format of full wave rectification. In case of it, this is half wave rectification. This is half wave rectification. In the case of a half wave rectification, okay, we will be able to use only one diode. We'll be able to use only one diode. through which we will be able to get half wave pulses, half wave rectification pulses, and this is full wave rectification pulses. Here we have been we are able to see, okay, the half cycle of a wave and another half cycle of a wave. It comprises a complete full cycle of one wave. So if I do just like here again a half wave. So what exactly? This is again another frequency. So from the first frequency, we are getting this pulse to here in the case of half wave. From the second frequency, this is our first frequency. This is our second frequency. From the second frequency as well, we will be able to get the second pulse. Here is a gap. Here is a gap between the two pulses, which is also a gap in between. In the case of a DC output of half wave rectification. And again, it is possible through single diode.